Okay, so this is chapter 3, example question past year. Okay, so given Vt is equals to 12 cos 10t volt. Okay, the first question is to find the equivalent impedance Zeq, and the second one is to find the current I1t, I2t, and I3t, and the third one is to find the voltage VRT and VLT. So given in the circuit, this is I should use red one. Okay, so this is I1t, okay, and then given I2t is here, and here is I3t. Okay, what else is given in the circuit? Here is positive, negative VR, and then the third one is asking VLT. Here is positive, negative VL. Okay, so they're asking in time domain, right? What else given in a circuit? I think that's it. Okay, so we have here 4 ohms resistor. Here is 16 ohms resistor, and this is inductor 2 Henry, and this is capacitor 7 millifarad, and this is inductor 2 Henry. Okay, so first of all, since they are given the value of inductor and capacitor, okay, using Henry and Farad unit, so you have to change the value into a frequency domain. Okay, in order to solve for the rest of the question, we need to change the unit into frequency domain. So here is for okay, this is for 2 Henry inductor. Okay, using formula J omega L. Okay, J omega is 10. Okay, omega is 10, and our L is 2 Henry. So you get the value J20 ohm. So here is 2 Henry inductor, and another one here 2 Henry inductor, and we have another one is a capacitor 7 millifarad. 7 millifarad capacitor. We change it using a formula 1 over J omega C. 1 over J, and omega is 10, and C is 7 milli times 7 times negative 3. Okay, so here you will get the answer negative J 14.29 ohms. Okay, so this is the transformation into a frequency domain. Okay, so this is the transformation into a frequency domain. Right, now the question is, the first question is asking to find Z equivalent, which means the equivalent impedance, Z equivalent. Okay, so how are we going to find for Z equivalent? Okay, in order to find the Z equivalent, so normally how to read Z equivalent is the total impedance for this whole circuit. So the total impedance, since this is the voltage source, so the total impedance we can see through here. Okay, so here is Z equivalent. Right, so from here, from the voltage source all through the all the components, okay, and go around the loops, all the loops. Okay, so we will get the Z equivalent. So in order to get the formula for Z equivalent, we have to know the components of resulting impedance inside the circuit. Okay, so how are we going to do this? How are you going to do that? Okay, so let's say I name here is 4 ohms and 2 Henry. Okay, I name here Z1. Okay, and then 16 ohm here for this node until here. For this node until here, I name it. They have a resistor and an inductor. Okay, so we name it into Z1. And then from this node to this node, they have one resistor here, 16 ohms. So we can name it as Z2. Okay, and the third one from this node, okay, down until the ground. Okay, to complete the loop, we can name 7 millifarad and 2 Henry inductor together as Z3. Okay, so according to what we have grouped here, okay, according to what we have grouped here, we can determine Z. Okay, Z1, let's say, okay, Z1 is equals to 4 ohms plus 2 Henry. We have changed it just now. 2 Henry is J20 plus J20. Okay, so the unit is ohm. And then we have Z2. Z2 is equals to 16 ohms. And then what about Z3? Z3 is equals to 7 millifarad. 7 millifarad, we already changed it into negative J 14.29. And then VL is, 2 Henry is J20. So we can add them up together. J20 minus J 14.29. Okay, since both of them is in imaginary form because they have J component in front, so we can add them up. Okay, so it becomes J 571 ohms. Right, so these are the three components of impedance. Okay, the three components of impedances. Okay, so we can label here impedance. Okay, the three components of impedance that form a resulting Z equivalent. Okay, how to form the formula for Z equivalent? Okay, so from here we can form a formula Z equivalent equals to, look back to the circuit. Okay, so here is Z1 from the source. Okay, Z1 from this node up until this node. Okay, and then before it divided into two branches, to these branches, into I2 branches and into I3 branches. Okay, so now Z equivalent, okay, is equals to Z1. Okay, here is Z1 plus, because this is in series with both of this, it's in series, Z1 is in series with both of this branch. Okay, so plus Z2 parallel with Z3. Okay, so we can solve here. Z1 is 4 plus J20 plus, okay, Z2 is 16 ohm. Okay, since Z2 is parallel with Z3, so we can use, okay, so this one we can use like we can spread it into Z2 times Z3, and then the bottom part we add them up. The top part we multiply, and the bottom part we add them up. Okay, so here we can write the upper, fill up the formula. Okay, Z2 is 16 times J 571 is Z3, and the bottom part we add them up, 16 plus J 571. Okay, now solve this equation. Okay, you can solve this complex number, and you manage to get, okay, use your calculator to solve this complex number, and you manage to get Z equivalent equals to 5.81 plus J 25.06 ohms. Okay, so this is your Z equivalent. Okay, so this Z equivalent that we obtain here is in rectangular form, so we would like to change into a phasor form. Okay, a phasor form will be, okay, we change it into a phasor form. Okay, so we obtain it 25.72, and the pseudo is 76.95. Okay, so this is the value of Z equivalent in phasor form. So the unit is still the same, which is ohms. Okay, so here into the phasor form as usual. Okay, how we are using the formula. Okay, in order to get the amplitude Z, okay, equivalent equals to. So as usual, we can use this formula to change from complex number, okay, or rectangular form into a phasor form using the formula Z equivalent equals to A squared plus B squared. Okay, where the A squared just now we obtained is 5.81. Okay, 5.81 squared plus, and the B is 25.06. Okay, you square root it all together, and you will get the value as 25.72. And then for the theta inside here, the angle theta is equals to tan -1 B over E. Okay, then you will, okay, you substitute B and A. Okay, you look at here is B 25.06 and A is 5.81. Okay, so you substitute and you manage to get theta 76.95. Okay, 95 degree. Okay, so this is it. Now the second question for this question, okay, is asking the current I1T, I2T, and I3T. Okay, so how are we going to get current? So by using the current divider rule, okay, so we can obtain the current value by using the current divider rule, right? For I1, I2 and I3, we can obtain it by using a current divider rule, okay, because from this node it breaks into these two. This is the main current I1 from the source, and then up to this node it breaks into two currents, which are I1, I2 and I3. So for I2 and I3, we can find it by using current divider formula, okay. Whereas for I1T, we can use the normal Ohm's law, which is V equals to IR. Okay, so first let's find out for I1. Okay, so I1 using the Ohm's law, okay, Vs over Z equivalent. V equals to IR. Z equivalent is referring to the resistance, okay, for AC circuit. Okay, so what is Vs and what is Z equivalent? Just now we have obtained for Z equivalent. So now what is Vs? Vs is given in the question, okay, as you can see here. So Vt is given here, Vt, or we can note here normally as a source, Vst, right? Okay, so it's given Vst. Let's see, I rename it as Vst. Is given 12 was 10t. Okay, so we can get from the question itself, okay, we can get Vs is equals to 12 and the angle is 0 volt. Vs is equals to 12, okay, 12 here, and there is no angle here, so 0. Okay, so we get Vs 12 with an angle 0. Okay, so here our Vs equals to 12, 0 divided by Z equivalent just now here, 25.72 Z equivalent, 25.72, and the theta is 76.95. Okay, Z equivalent 25.72 and theta is 76.95. So we can divide this now, okay, the outer part we can divide it as usual. 12 divided by 25.72, we managed to get as 0.47, and then inside here, okay, theta we will get 0 minus 76.95, so we will get negative 76.95 degree. Okay, so this is I1 value in phasor form, so ampere. So this is I1, but the question is asking you to find I1T, means in time domain. Okay, answer in time domain. Okay, so how are we going to answer in time domain? Simply change from here into a time domain format, which is I1T, okay, equals to 0.47 cos, okay, cos our omega is given a question, given, we take it back, here is the omega, okay, 10 t, okay, omega t. Oh, why are you doing the jumping? Oh no, udah macam mana lah, loncat dah mana dah tu. Oh no, sorry, ada ikan haruan dah lompat dari ikan haruan. Oh my mother, alamak, dia dah lompat, macam mana saya nak angkat tu? Sekecil saya. Si, dia ikan haruan. Alamak, macam mana saya nak angkat dia? Ikan haruan itu my mother-in-law, dia baru lepas operation. My friend bagi ikan haruan hidup ni, saya letaklah dalam tu periuk dia, tapi dia dah lompat. Dia kuat sangat nak boleh lompat saya, padahal saya dah letak periuk berat satu atas tu. Oh no, macam mana saya nak angkat dia sekarang? Tinggal saya seorang je lewat malam macam ni. Oh no, tengok ikan ni, dia boleh jalan aja. Siapa nak angkat macam ni? Tadi bergerak. Saya dah santai tadi. Aduh, dia bergerak-gerak lagi. Dah pergi mana lagi? Sama. Okay, sama balik. So we managed to get I1T equals to 0.47 cos omega t is 10t. Okay, 10t minus 76.95. Okay, okay, so ampere. So this is the value of IT in time domain. Okay, now we proceed to find I2. So I2 we can find using current divider rule. Okay, find I2. Okay, using current Terkejut-kejut je. Macam mana nak buat kerja macam ni? Sabar je lah lepas ni. Using current divider rule. Divider. So I do we obtain it using current divider rule. Okay. Bertenang. Lepas kadang-kadang I2 equals to, so this is the current divider rule, Z3 over Z2 plus Z3. Okay, so I1. So here is the formula for current divider rule. Okay, so macam mana kita dapat this one? Let's see the circuit here. Okay, so here is I2, right? Using current divider rule, we will get on the other branch, which is Z3. Z3 duduk di atas, and the bottom part will be the resulting of these two branches. Okay, these two branches, Z2 plus Z3. Okay, so times with I1, because I1 is the source current that coming into the node. Jangan duk lompat lagi ya, jangan nak terkejutkan aku lagi. Sama dengan J. So ganti masuk, right? Okay, we fill up the formula using this Z1, Z2, Z3. Okay, the value that we obtained just now. Excuse me. Okay, please be nice to me. Okay, Z3 is divided by 16 plus J 5. Oh ya Allah Rabbi, macam mana saya nak teruskan ni nanti sekejap. Okay, sambung balik. I1, okay, now so Z3 plus Z3. Okay, and then I1, just now we obtained here I1. Okay, kita pakai the phasor form lah, so easier. Negative 76.95. So macam selalu, okay. Alright, so we solve for this one. Okay, the complex number here, and here we janganlah ngamuk-ngamuk macam tu. 0.34 71.03 darjah. Okay, so we solve for this complex number and you get into a phasor form. Okay, sama juga nak tukar daripada satu bentuk complex number pada phasor form using this formula. Okay, this formula and this formula. Okay, I think I have shown lots of that kind of transformation. Okay, so I think you need to do by your own self this one. Okay, solve the complex number first, and then you change it to a phasor form. Okay, so and times back with this one for 76.95. Okay, and then di luar kita boleh darab macam biasa, and you get 0.16, and the theta negative, this one. The sudut be at them both, okay, but positive, negative, so you get the value. Okay, so you get a value negative 5.92 degree. So this is the theta. Okay, so this is I2 in ampere, but same like I1, the answer should be in time domain. Okay, so simply change it into the time domain form. I2 t equals to 0.16 cos omega t is 10t minus 5.92. Alright, this is the answer for I2. Okay, answer for I2. Okay, next moving out to I3. Using the same, using the same current divider rule. Okay, nak belajar, sabar-sabar. Saya pun tak tahu apa nak buat dengan ikan ni, nak still tak dapat angkat dia lagi. Okay, so current divider, menggunakan the same method, current divider rule, so we can get I3 equals to okay, kita tengok balik the circuit here. Okay, so where is I3? Here is I3. Okay, so at this branch, so using the using how to use a current divider rule. Current divider rule for I3 will be Z2. Okay, the atas will be Z2, and the bawah is Z2 plus Z3. Z2 plus Z3. Okay, all this kita times with the source current, which is I1. Okay, so we fill up the formula. Z2 is 16 ohms. Z3 is plus J 5.71. Okay, and I1 is 0.47, negative 76.95. Okay, so kita solve. We solve for this complex number first, macam biasa, and then we change into phasor form. you managed to get okay, 0.95, negative 19.7. Boy, agresif betul ya. I think saya dah boleh adapt sikit dengan bunyi tadi, terkejut sangat first time dengar. 0.95 and the sudut is negative 19.78. Okay, 0.47 ni salin balik. Okay, so this is I3. Okay, darab dan luar darab macam biasa, yang dalam kita tambah. Okay, so you will get your I3 sama dengan 0.45, and the angle, okay, negative 96.73. Right, okay, sama juga, we have to change it into the time domain form. So 0.545 cos 10t is omega t, and this will do it at 673 ampere. So this is I3. Okay, so just saya nak okay, just saya nak betulkan yang hari tu, lecture hari tu. Okay, so this is a complex number. Okay, so I try to count this one here. Okay, complex number. Okay, you solve this, you will get something like this. 0.89 minus j equals 0.32. Now, what's the problem then? Mana dah tutup? Okay, ada lagi. Dia dah sudah kena serkup. Okay, 0.89 tolak 0.32, so you will get this one. Okay, when you solve this one, you will get like this. Okay, so in order to get change this into a phasor form, right? We want to change it into phasor form. Okay, so macam mana tadi? The z will be any z. Okay, A. So this is A, this is B. Okay, A kuasa 2 tambah B kuasa 2. Okay, A kuasa 2 is 0.89. Okay, plus 0.32. Right? Oi, janganlah terkejut ni. Okay, then you will get the answer 0.95. Okay, you try to do it, whether you can get it or not. Okay, and then untuk theta, so here lah tadi. Okay, and the theta will be tangent negative 1 B over A. Okay, so last time I said ambil dia punya absolute value, but no. Okay, I have checked it. Okay, we take it the negative value here, negative, right? Okay, so B is negative, so means B is negative 0.32 divided by A is 0.89. Okay, so you will get here the answer for negative 96.73. Okay, so this is theta lah. So that's why we get here, sorry, 19.78. Sorry, yeah. Negative 19.78. Okay. Okay, so this is theta. Okay, so this is our theta. Okay, then you solve it and you get I3 and change it to time domain. Okay, let's go to the last question. The last question is asking you to find for VRT and VLT. Where is V? Here is VRT and here is VLT. Dekat 2 Henry and VRT at 16 ohm. Okay, so we can simply use the Ohm's law here. Okay, so question 3. Okay, so VRT using the Ohm's law. VRT is I2. Okay, I2 times with 16 ohm. I2. Okay, kejap. Okay, saya nak kacau sikit. Okay, so VRT sama dengan I2 sikit lagi. I2 Z2. Okay, so here we will get I2 is 0.16 tadi, 5.92 times 16, and you get the answer 2.56, negative 5.92. So sorry, this is not VRT yet. Okay, this is not VRT yet, so this is in phasor form. Okay, so now we change VR. Since the question is asking you here in time domain, VRT, VLT in time domain, so we change it into a time domain. Oi, tolonglah sikit, janganlah bagi orang terkejut je. 2.56 sikit lagi. Cos 10t, ambil balik dekat question 10t, right? Or omega t, negative 5.92. Okay, so this is the answer for VRT. Okay, manakah dia? VL. Okay, VL pula kita dapat. Here is VL sama adik. VL here. Okay, using also I3 darab dengan 2 Henry. 2 Henry kita dah tukar tadi J20. Okay, balik tengok. So VL2 here pada 2 Henry. Okay, I dia ialah I3. R dia ialah 2 Henry. Okay, so the 2 Henry just now we have changed. Here J20. Okay, so I3 kita tadi kita dapat janganlah. So I3 is here 0.45. So sudut negatif 96.73. Okay, here is I3. Yang J20 kita tahu J20 is sama dengan J20. J20 kita tahu J20 is 20 per sudut 90. Oh, tak mahu dekat atas tu. Bolehlah tu ya. Alright, so kita darab macam biasa dekat luar ni, you will get okay, so this is the value we will obtain for BL 9. Okay, this is the sudut both. Okay, so sama juga. Now we are going to change it into time domain. BLT sama dengan 9 cos omega t is 10t negative 6.73. Okay, that's it. So selesai lah untuk kesemua soalan contoh pasir. Okay, I hope that you can understand this.